Well, hi guys, welcome to Matrix Uploaded. We're continuing with calculus. This is the amazing section, tangents to curves. Okay, very important section of the syllabus. Let's rock and roll with this wonderful section. Determining the equation of a tangent to a curve at a given point. Okay, now what is the important thing that you need to know about a tangent to a curve? What is the gradient of the tangent? Well, it's the gradient of the curve. So the gradient of the tangent to a curve at a point is the derivative at that point. Okay, very important. Gradient, slope, rate of change, derivative, all means pretty much the same thing. And what it really talks about is this. Now I'm going to show you. This is something that is really the heart of calculus. Okay, if you've got any curve, okay, a function or whatever it is, there's a cubic, and at a specific point, you draw a tangent to the cubic. Parabolas or any other graphs that you like. What do we know? At this point over here, wherever that is, okay, the gradient of the tangent is the gradient of the curve. Okay, and really the gradient, if whatever that point is the gradient, it's the derivative at whatever point. It's called it a, it could be dx, it could be anything. The gradient of the tangent is the gradient of the curve at a specific point. And what do you need on a curve? You need to get an equation of a tangent, for example, that's a line. You're definitely going to have a point on the line, and you're also going to have the gradient. Y equals mx plus c. Very important. So how do we proceed with this wonderful thing? Watch this. The equation of a tangent, it's a line, guys. It's a straight line. Y equals mx plus c. Or what did you do in analytical? You said y minus y1 is mx minus x1. Do you remember that? Look at that. Now, I love this formula because y1 and x1 is really a point on the line. If you look at that, x1, y1 is really a point on the line, on the tangent line, and the gradient of the tangent is the derivative at that x value. So when you differentiate the function, you can get the gradient of the tangent by substituting in that x value. And so that's where derivatives come into play. Now we know the gradient of the tangent line is the gradient of the function there. Okay, now let's look at something else. Okay, gradients of tangent. These three bits, the m, the x1, and the y1, are needed to get the equation of the straight line, which is a tangent to the circle. Okay, now let's have a look at an example. Here we've got a graph. Okay, we're going to get a little cubic graph. We're going to determine the equation of the tangent to the graph of this cubic at a point x equals minus 2. Now remember, in the previous lesson, we sketched the cubic graph. Okay, so don't worry about that. What we want to now do, and I'm going to give you the picture, but we are going to find the gradient of the tangent at minus 2, but we're going to have to find the coordinates of a point on the tangent line. Okay, so let's have a look. Well, here's my cubic graph. Don't worry about it. It's a happy one. We've already sketched it previously, but that's the graph of the cubic. Now, there's the tangent line to the curve. Okay, and what do we want? Okay, if we want to determine the gradient of the tangent, if you look back there, you can see clearly what do we know. If we have a look at this, here is where the tangent meets the curve. And at that point, x is minus 2. So you've got an x value. We normally call that x1. We don't know what the y value is that we need to find out. And we also need the gradient of this line. The gradient, which is, by the way, the derivative at minus 2. Have a look at the slide. What does this mean? The derivative. If you can get the derivative and plug in minus 2, you can get the gradient of the tangent. So we've got x1. We know what x1 is. It's minus 2. We don't know what the gradient is, and we definitely don't know what y1 is. So we're going to have to explore that if you want to use this equation. If you want to use this equation, you're going to have to, you've got that, you're given that, that's minus 2, no problem. We need the m and we need the y1. Those are important concepts that we need. Okay, so let's continue with this and let's see what we get. The gradient, let's differentiate. Now, how do we do the derivative? Pretty straightforward. Let's use the rules of differentiation. How do we do that? Well, the derivative, bring down the 3. 2 times 3 is 6. Subtract 1. The derivative of minus 6 is 6. And the derivative of negative 4 is 0. And of course, we then plug in negative 2 because that's what we want, the gradient. So 6 times negative 2 squared minus 6 gives you 18. 6 4s are 24 minus 6 is 18. This is the gradient of the tangent at minus 2. It's a positive gradient. The line is sloping to the right. That is exactly what we want. Okay, now the y value. How do we get the y value corresponding to the given x value? How would we do that? Well, you go to the original and you plug in, you substitute in into minus 4. Okay, so please be aware of this. Then you work out what the y value is there. Okay, so in other words, we know that the x1 is minus 2, but this is the y1. Okay, please be aware of this, guys. So what do we know? We can immediately substitute the value in, and we've got y minus y1, m, and x minus x1. Okay, and then you tidy it up, and you then simply work it out. Y plus 8, and you get your equation of the tangent. Stay with us on Matrics Uploaded. We're going to look at another example in the next lesson.